Today we're doing a test cut using a Forest Manufacturing Model 480 HD horizontal blade bandsaw. The HD is an evolution from our Model 480P. The Model 480P stood for pneumatic. This still has the pneumatic, but it has hugely upgraded bearings. The wheel support bearings on this on the standard 480, 480P, most of our other machines are ball bearing style bearings, usually running on about a 1.5 inch shaft. For this machine, I have some customers who are just really hard on the hardware. So we have upgraded this machine to spherical roller style bearings. We've jumped up to an 1.75 inch shaft, a spherical roller bearing, which has about 3 times the basic bearing rating of a similar sized ball bearing. So they can beat these and they'll put up with it. The bearings are fussy. First off, they're expensive. They're very fussy to install. They are an adapter mount bearing. And if you're not familiar with that, it's basically kind of a wedge-shaped collar that locks the bearing firmly onto the shaft. It's a great way to locate a bearing, but it is very fussy to install. But since the bearing should last so much longer, that hopefully will be much less of an issue. Today's test cut. We are working with a 4-pound mineral fiber material. I have here a sample piece about 3 inches by 9 inches, and I have a potential customer who wants to work with material similar in size to this, still 4 pounds, similar size, and he basically wants to do a diagonal cut across the corners to make 2 wedge shapes. His exact cut is a little different configuration, but I'm working with what I have today. But the idea is the same. So he wants to make a wedge-shaped taper. Now there's 2 ways to do this. I can have the workpiece on a table and tilt it like this to make the cut, or I can have it run through longitudinally and tilt it like this. So I can either tilt it front to back and run it through broad way across, or I can run it through this narrow way and tilt it left to right. This way the blade is engaging in much less material. The actual potential customer, his workpiece is 60 inches wide, so if I did it this way, I would have the blade engaged in 60 inches of material, and that gives a lot of opportunity for things to go wrong. By running it through the narrow way, the blade is only engaging in the square root of the sum of the squares of 3 and 9, whatever that number is. So we're going to try this with a couple different blades. The first blade is the blade I hope works out for this. It's a 1 inch wide scallop edge blade. Looks like a bread knife. It's basically a knife style blade, but it's good for cutting hard materials like this. It gives a beautiful, clean, fuzz-free, dust-free cut. But it takes a little more effort to get it through. It's having to, since it doesn't create a kerf, it doesn't carve out a channel or slot of material, the blade has kind of wedged through the workpiece. So just like you couldn't use the bread knife at home to cut through the limb of a tree or a 2x4, because it just cut in and wedge, on a really high density material, the knife blade doesn't work. If we have a problem with this, I will fall back to a fine tooth hook style blade, something like a 1 inch wide, 24 tooth per inch blade. I know that'll cut it. It won't be as nice a cut. So we're going to start here. To make the cut and do that left to right tilt we discussed, we have made up a little fixture here. So the idea, obviously, is to preset the angle to run the material through, and I have the material with the cut I want going basically corner to corner here and a little above this fixture I've made. And then I have already set the height of the blade to catch those corners. This is the first time I've made this cut on this machine and this material, so I think it's going to work. Let's find out. Over here the machine has a typical control panel for us. We're running, for this application, it's way overkill. We got a 5 horsepower brake motor on there, pneumatic blade tensioning, 60 PSI on the gauge. Probably gives us about 20,000 PSI on a blade like this, so plenty of blade tension. This machine has an electric solenoid to control the blade tension, so flip a lever, tensions, detensions. We have red and green stack lights here. I believe you can see this where I am. Where if I disconnect The airline, we get a flashing red light, nothing works. If the blade breaks, we also get the flashing red light, you can't do anything. But start stop buttons, we have a fuse disconnect in the panel, we have a magnetic motor starter with an overload, and some basic logic in here, 120 volt control voltage. But press the start button and exactly what you expect happens. Does somebody have like a pusher box or something I can use to push this through the last few steps? Do you have like a, I should have thought of this before. What do you have over here? Yeah, a pusher box. I don't want to push the thing all the way through myself by hand. I should have thought of grabbing this before. 2x4s. Long enough?
Or I've got a longer one.
Yeah, give me those, both of them. I wasn't fully prepared. Perfect. Those nailed together? Nope. Okay. And what that was all about is I'm going to start pushing this box through manually, but I don't want to get too close to the blade myself, so once I get it good and started, I'll use some sticks to push the box through the rest of the way. Well, let's find out what happens here. I think we have a winner. So we have a little bit of fluffing of this edge, but I think that's because the top surface of this workpiece is all kinds of lumpy. So this point where it breaks through is bad. This particular material, I guess this was the surface, as it came out of the surface, is nice and flat. So we have a really nice, crisp edge there. This corner being a little whopper jaw, as I believe, just because the workpiece is a little wiggly. Here's the other piece I had. So you can see the upper surface of this workpiece is just weird. So there's not a nice sharp corner to track along there. But I think we're good with this machine running a 1-inch scallop edge blade. If you have any questions, please feel free to call us here at Forrest Manufacturing. Thank you.